let's look at this problem. We have a spring dB, so there's a spring here, has an unstretched length of 2 meters. So the unstretched length is 2 meters. And we need to determine the stiffness of the spring to hold the 40 kilogram. This is here 40 kilogram crate in the position shown. And he wants to know K, the value K, the stiffness of the spring. Let's look at this analysis. So first of all, we have to draw a free body diagram. This is the x-axis, and this is the y-axis. Let's look at this point. Point D, which will cover all the cables. Cable DB, cable DC, and then the weight. Of course, we should not take the weight as kilogram. We have to multiply kilogram times 9.81. So this one going to be 40 times 9 to convert it to Newton. The angle you can see here, this is 3 and this is 2. So I'll do it like this, 3, 2. And you can see that this is 2 and this is also 2. So this is 2, 2. When you do 2, 2, and that is 4 and 4 square root of 8. And this is 4 and 9, that's square root of 13. So now we have, we could formulate our two unknowns to equation. Okay, so summation of forces at x equal to 0, and we're going to assume this is positive. dB 3 over square root of 13 minus dc 2 over square root of 8 equal to 0. And that's summation of forces of y equal to 0. This is our assumption is positive. dB 2 over square root of 13 plus dc 2 over square root of 8 minus 40 times 9.81 equal to 0. So we have all the forces. We should put this into the calculator. So dB is equal 283. That is in, oh, of course, Newton, because this is in Newton, sorry. Should put this here. This is in Newton. And DC, the calculator shows 333 Newton. Okay. And they both, of course, tension. So he gave you the unstretched length of 2 meters. Now we need to find out the stretched length. This is after applying the weight. This is the stretched length. So the stretched length is equal to, remember we just found out it's square root of 13 meter, and that is after the spring is stretched. So we'll just do it again. This is the actual stretched of the cable with the weight. So this is S. And now we found out it's square root of 13. Okay, so now we should find the unstretched is 2 meters and the stretched is square root of 13. So we should find out, remember to find out the equation of the spring, it's force, K, remember X, and X is the extra elongation of the spring. But now we have the force, and this is force, of course, dB. dB, we have it as equal to 283. K is unknown. Now we need to find X. So X, we found it here. This is the extra elongation, which means that the cable after the stretched, which is square root of 13, minus the original length of the unstretched spring. That's 2. So let's find this. Uh, 13 square root minus 2, 1.61. Okay, and then this is X, you put it here, times 1.61, and then you could find K as 283 over 1.61, and that will give you 176. And of course, the unit, as we have before, it is Newton per meter. That's K. So that's what we want, K. In this problem, we need to make sure that drawing a free body diagram is a must. If you don't draw it, you will subtract minus 5% of the problem. You have to write the equation and you have to state your assumption. You make sure you put the magnitude and the units, magnitude and units. And of course, all the time, magnitude units. And make sure that you look at the problem, and this is a very easy problem, but I hope that you understand it.